thanks for coming. Do you know if members of Dr. Rasul's group are going to be here?
Maybe. I'll send a message.
Is that a challenge?
No. Sounded like it.
Oh, I'm going to walk and watch what is there. Yeah.
I recommend tape.
So, if you have observed the slides that I shared, they look quite big, like 35 megabytes, but most of it are useless. The most important part is what I'm distributing now. The rest is just fluff. So it is from Minneapolis?
Yes.
So it was inches, not feet.
Yeah, I think it was actually millimeter measurements.
Yeah, there was another attachment on that.
100 millimeters long by about
There was another attachment on that.
So the next challenge is to pull orbitals overlap this. And there is one more piece. So Gage and Ben are certified experts in the subject of today's meeting because they did attend it about half a year ago. So it is I'm following a template. The goal that you're going to pursue, you need to do something that I do not know how to do. So you need to jump up and show high performance. You need to write. And you cannot take me as an example, neither in writing nor in public speech. And although I'm not very skilled in this, I'll try to share some general notes that will help all of you to succeed in the rest of the course. So there is a you have already obtained sufficient amount of skills in theory. Oh, no. So you've got enough skills in theoretical background of methods, and last time maybe it was a little intense, but I hope to share last lecture in recordings. And as you see from this diagram, that you may get tired of watching each time at the beginning of the meeting, that on lectures we are covering theoretical background. Then on first part of practical skills you were building models, and most of the time you were running right software and right hardware, and you are in the process of computing observables, right? Eventually maybe comparing with some experiments or your intuitive expectations. And there is one part that we didn't cover much. You did it partially when you were presenting skills, but the reason for all activities that we did here. The reason of all the theories and practical skills are research activity, which you may need in your careers. But research activity cannot exist in isolation from other people, and just by nature of human society and scientific activity, it includes scientific communications. So this is a separate skill that needs to be added to theoretical background and practical achievements in your research projects. And this part is not connected to this course. It's very generic, and maybe you already got your excellence in this activity before. Some of you are already research active, some of you have peer review competitive publications and went through this procedure, but we need to stay on the same grounds and get to the level where we can bring your mini research project on the orbit comparable to true life, or it is brought for review for professional experts. Sorry, you get better attendance. This is a summary. If you look on it, you do not need to listen to me. Although you're welcome to.
I will.
Oh, thank you. So, yes?
I'm sorry, I have a question. What do you mean by radiative times?
Einstein coefficients.
Okay.
As soon as you know the value of oscillator strength, you can immediately compute tau, the Einstein coefficients for spontaneous emission.
Okay.
And if you need a specific code for it, I'd be happy to share. By some, like this class this year gets very successful, but by some objective reason, maybe because you are putting all thorough focus on each subject we study, we didn't get over too much of practical skills because we are trying to perfect each one. So we are doing analysis of let's put this here. What? Summarizing data and organizing results in form of written report. So you're doing projects. This one is by me. I didn't have time to complete this little graphical summary of everything you do, but I had intention to go over your directors and summarize. So the projects that you're doing range from photo-induced depolymerization to PN junctions, so which makes connection to photovoltaics. Then there are high temperature chemical transformations, combustion. There are properties of specific polymers, both electronic and mechanical. There are interface between organic and inorganic materials, and the author of this work, here is the gold medal in all the skills of passion holder. Can you pass it to Nas as well? So I just pulled this thing from directory of author of this project, who is in green color today, and who is carefully studying materials. And he may see the recordings that, interestingly, remember we went over spin polarized electronic calculations, and the orbital with the same number may have a drastically different character, localization, and symmetry for spin alpha and spin beta. So it can be so radically drastically than for beta, it is localized in different parts of the material, and it is something non-negligible.
Is that a bipyridine group I see attached?
Yes, it is.
Is that ruthenium?
Yes.
That's mine.
Well, it was democratic procedure of selecting what.
I know. I'm just teasing. It wasn't real. I mean, it was. I did put that on my quantum dots, but it was a long time ago.
But it's a very challenging system. Anyone who takes it is very brave. There is a project on web Telluride nanowires, and then this. You already got the printout. And let nanowires in the interface with metal contact for thermal electrics. Also, there are projects that focus on more electronic rather than chemical properties and localization of charges for the ignition. And some, I need to regroup it, like chemistry to chemistry, like what gauges do it should go together with this one. And the chemical reactions introduced by heat. And those are summaries from previous years. So I will mumble a lot of disorganized, unnecessary information. I'm just looking in a sober way at the things that I'm doing. You need to do much better, because I have the luxury to speak intellectual garbage for 2 hours, and you need to give condensed presentation in 5 minutes. And for writing, you should keep the figure of like 4 pages.
Including pages?
No. You will. Some of you may think, "Oh, 4 pages, so much." But as you start writing, I promise, there will be maybe 1 out of 11 papers that will be 4 or less. Most of you will blow the size of the papers to like 10.
The people with the chemistry background. Another model.
You will need to keep yourself in the bounds.
Oh, right.
It is not easy. So although I am admitting that some things that I'm going to present are disorganized, you need to, with this disorganized talk, I want to inspire you to be very organized in what you're writing.
Okay.
And there will be some items that may eventually help you to excel in this activity. So there will be several segments of what I'm showing. There will be a segment on research procedures that we covered before. There will be a segment on organizing of data in figures and tables, what you're already doing, especially those who successfully completed the last homework, which was like number 9. And there will be 2 more sections. Section how to organize the data that have already been organized in a human story. How to explain it with a human language in a way that someone else can read it. Some of you are very talented and can do it naturally. Some people, like myself, finding it hardest problem in the life. So I'll provide some little algorithm how to explain what you're doing for research in writing. And the 4th part will be heads up of the reviewing procedure. So I'm not going to keep intrigue. When you will come after the weekend on Tuesday, I'm asking everyone to bring printed copies of your written reports, like 4 pages of text plus whatever figures, right? 3 copies. And why 3 if I'm the one instructor? Because there will be a reviewing procedure in a random way. Each of you will serve as reviewers of someone else in the class. And your reviews will be counted towards success in the course. So I'm going to disclose what will be the criteria for grading. Criteria that I will use for grading of your written reports, and criteria that those of you who will play a role of reviewers will apply towards other works. And through understanding of this procedure, you may develop an idea how to organize your writing effort. So if you know what is required, you can intentionally put right things and skip wrong things. Right? And I'll give you a heads up when to focus and when there will be something important. And when it is non-important things, you can keep relaxing.
Question.
Please.
So you said by Tuesday we should submit a full, all of
Final report.
final.
Final written report.
Make sure.
No. So you may hate or you hopefully love this figure, but you are acquainted with it, right? So one of the idea is that we explore how the properties, electronic properties of material respond to change of the geometry by molecular dynamics, right? And this is not ideal, but it is one of the possible general ways to organize research in a short time. Skip this. This table doesn't want to be skipped. And we need to design some format how to present the data that you have. Here, I brought only one example, but I can send them by emails. It is one of the papers that grown out of a seed of course projects in the past. And there are 2 copies you can circulate, and I don't have enough copies to leave it with you, but if someone wants, it is fine.
Wait, these are actual published papers from this class?
Well, I will not lie. After completing class project, there were additional steps of improving both results and writing. But without class, it will be not possible. Class is like substantial core of the publication.
Okay.
Here is an example of figure whatever, number 2. So if you scroll through, it shows how data can be organized. So this is one of the figures. And this year, this figure is closest to near and dear to the heart of Nathan, because the subject of this paper is p-n doped silicon, same as he's doing, but with some different geometry. So this is response of a model to presence or absence of doping and to thermalization. So I don't have intentions and we do not have time to go over things. You do much better science yourself, but the way that you can have several examples of the same type of results, such as density of states, for different configurations, without doping and with doping, or with doping at 0 Kelvin and after you do thermalization. So you do see that evidently thermalization can screw up or improve electronic structure substantially. And being excited, it is what meat is doing, right? Exposing, removing a little bit from valence band and putting a little bit to conduction band. So another little comment that some projects, and what I'm doing is very hard to make pleasant and directly applicable to each project, but some of you will see similarities and correlation with what is being discussed. So some projects can be symbolically, some models that you explore can be symbolically split onto hybrid systems that compose of part A and part B that are being brought together, right? And A and B can be very different in each project. And then it is very, very standard situation, and there are standard moves, standard ways how to describe it. For example, one can look on the characteristics of system A and characteristics of system B, for example, density of states. Then look on density of states of system A and B together and see how much their property of the combined system can be expanded as literal addition of the properties of system A and system B. Even simpler than this. Binding energy. So some people earning, how to say it, salaries.
6 figures.
Huh? 6 figures. No, just surviving, but one can professionally survive without going too far and too deep into computational details. Like you can look onto a lot of experimental situations, a lot of experimental like molecules and materials, and support them or maybe offend them through computation by checking if the experimental measurements are right or wrong. So it is a very standard thing if two objects A and B merge together, if they want to merge or not. So so-called binding energy. And this is probably the most basic thing what one can do. So compute total energy of the combined hybrid system, total energy of the system A and system B, and see how far summation of total energy of A and total energy of B is offset from total energy of the combined system. So if you do it again and again for different methods, it is sufficient to, not for 6 figures, but for surviving. You do not, so you do not need all information that you got in the course to. So if you identify that your system can be expanded onto such sections, you may decide to add analysis of binding energy. There is no general template for data. I'm trying to do it each year, and I'm failing because each project is very individual. But you can try to look over like ground, excited before and after molecular dynamics, hybrid or standalone sections, and then do some numbers for them, if you find it useful. I already, how to say, confessed that what I'm presenting now is disorganized, and it is. Only by the end of today's meeting, I will touch the most important question. The question of goals and expected outcomes of your paper. So a lot of researchers get really excited with technical aspects. Like, I love to draw orbital and I don't care who needs them, because I'm getting like, emotionally rewarded. But it can be pleasant personally, but it is not right general attitude. If you try to communicate results of your research, you need to clear understanding what is the goal and what you need to address, and who needs it. And I'm going to touch this thing that should probably go at the very beginning, as the last thing of today's meeting. But why I'm mentioning it, because if you are trying to organize your data, build tables, the criterion of doing or not doing some steps is understanding of your research goals. And for each of you, you are dealing with natural sciences education, and some of you with research for a long time. So your general intelligence, experience, and knowledge should be way more than enough to realize the goals, pose them, and then compare each step you're doing in your mini research project versus goal, either real or unreal. But you should crystallize and formulate which goal you're pursuing. Okay? Again, it is objectively hard to organize data. We all can do geometry, movies, density of state, spectra, orbitals. But those characteristics can be done for neutral ingrown state, for anions, cations, for excitations, and for singlets, triplets, for the magnetic modifications of electronic configuration. And then one can do it again for systems that has been perturbed by the heat. So even if we are not posing a lot of ambitious plans, it is a big variety of data that you have already generated or can generate at a no time. Those, if your system is small enough and you're submitting to debug queue, you're getting the results within like half an hour. So one needs a compass, one needs a realization of a main goal that you're trying to pursue as a navigation for selecting one or another numerical experiment and for reporting this numerical experiment in your written report and for including or not including specific data. This is the creative part of your research project that no one can instruct you. So it's, this is the main challenge in the course, in the project, and in the generally in academic life. Yeah, we already covered it. In case your system can be chopped onto segments A and B, one can always find binding energy. One can draw density of states of chopped pieces and overall pieces one after another and see if they look approximately the same. One can, if the system can be chopped, one can look on the absorption spectra of the independent items and then combine system and see if they look as the summation or bringing items closer to each other substantially perturb their original structure. Also, some people do not find anything valuable in orbitals. Some people hate orbitals, and some people love orbitals because they're a tool to understand the localization and delocalization of orbitals, charge transfer, and some magnetic properties. But we already discussed the question about the selecting couple of few orbitals out of large amount that could be most helpful. What are the criteria? Of course, one can convert three-dimensional objects into one-dimensional, plot all of them, maybe not in paper, not in file, but for yourself, and make a mark on a paper which ones look most interesting, and then plot. Right? Those that give better charge transfer, better localization, better delocalization, or better follow. They follow in the best way the progression of particle in the box. It's one of the criteria. Which other criteria for selecting orbitals one can do? One can glance into oscillator strength file and select those pairs of orbitals that give largest oscillator strengths. So it is one of the features. If pairs of orbitals contribute at most to ability of molecule to absorb energy in form of electromagnetic radiations, probably there is something special about these two orbitals and they're worth of plotting and analyzing. Again, a little disclaimer. Right now, you are shopping. I'm throwing in a lot of disorganized ideas, and you need to identify for yourself which of these ideas you buy and put into your written reports. what will be shown here is a little excessive. It's not possible to take all ideas and put in one report. And through your intelligent, creative activity, you develop your intellectual compass and your ideas, which data and which approaches, which intellectual steps are more appropriate for a project and which can be rejected or postponed for the future. Who has never heard of Arrhenius?
Heard of what?
Arrhenius.
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 Arrhenius?
Yes.
Today Maid was giving a presentation on Arrhenius equation.
What do you want to know?
No. That's good. Okay, who is confident with Arrhenius? 1, 2, 3. Who has heard about Arrhenius but not confident?
This Maid's was
4, 5. And who didn't vote? Okay. So there is a very basic idea that was exploited fruitfully in chemistry. You all have heard about like Boltzmann distribution. If energy provided is bigger than some threshold, then process is enabled. If less, it is not. And this idea is behind a lot of chemistry. If we are looking on the process of completing a reaction, one often has a activation energy that one needs to overcome. And if the activation energy is smaller than room temperature, reaction will be enabled. If activation energy is higher, it will be disabled. Or we can go in the other way. If you have fixed activation energy, we can scan different values of temperature. Annas was planning to scan only 3 values of temperature, but one can go over like 20 if needed. See how system responds to different values of temperature and whether it will create some drastic changes. Not all of us are doing projects related to chemistry, but what I can promise, each model has bonds between ions, and in this sense, each model has a little of chemistry. And each model, if heated to substantial amount of temperature, will experience bond breaking. I'm not telling that you immediately need to do it, but anything we do will evaporate to a plasma if you give it 20,000 Kelvin temperature, right? And in this sense, concept of activation energy is applicable to any project we do. So you can, one of the beauty of computational chemistry is that you can do explosion without any danger to a person who does this experiment.
Isn't that the fun part, though?
Huh?
Isn't that the fun part, though?
It is. It is. I always intend but forget because semester rounds up so quickly. One should do more explosives as a projects like known and maybe unknown. Initial conditions. This year we went through standard setting up of initial conditions. Just but temperature is set up by second part of a quant car file, where 3 Cartesian projections of momentum px, py, and pz are set up. If we are doing heating procedure, and all of us are doing that, it is set up by internal procedure in VASP. But no one forbids to manually set up momentum on any selected atom or group of atoms. So we are not doing it this year, but one can intentionally make a group of atoms to move in a certain direction and collide in a certain way. So, which data we may have? Geometry, total energy, gap, binding energy, density of states, spectra, orbitals. Well, temperature as function of time is not observable, but for some, if there is a combustion reaction, and we do, this year we have only one combustion, right? By gauge. You all know this little trick how to do grep T equals out of the Aussie car to follow the temperature. So when we heat system or do molecular dynamics, it does temperature does fluctuations around the value that we need. If system is big and we carefully heat it up, thermalize, then fluctuations are small. If system is small or we didn't ramp it up long enough, it will be big fluctuations. But in average, temperature will be constant because Sudipta knows the right keywords for this. NVT.
NVT.
So T constant.
Yes.
Right? Number of atoms constant, volume is constant, temperature is constant. But if you do NVT for combustion reactions, for exothermic reaction, overall temperature will start growing because energy is released and it gets hotter and hotter. So if KH did this experiment, he may witness that it happens or doesn't happen. If he didn't, it is one of the interesting things to check. And we all may check it. So if you see the temperature increases with time, it can be not an error of code, but a witness that there is an exothermic reaction. And opposite, if you see the temperature goes down, it could be endothermic reaction.
Basically, what happens to the samples? Like the chains, we have just like atom temperatures increasing. Is it just by looking at the?
You can. Again, same as with orbitals. A lot of people love movies, but some people hate, and some do not care, because it's a lot of graphical information that is, for some people, looks excessive. But if you convert complicated molecular dynamics data into just one line, as temperature as function of time, it is easier to analyze and make some conclusions. Typically, if you look on temperature as function of time first and then go back into movie, if you saw the temperature changes drastically, likely the bonds are broken or formed. If you're looking on gentle exploration in mild range of conditions, it shouldn't happen. But if you are looking for combustible, energetic materials, it's likely to happen. Energies of orbitals as a function of time. We didn't cover it. If there will be time at the last lab, I may cover it as a bonus. Okay, organizing data. All very challenging and all very individual. So it is one of the handouts that you have received, and it is very, very similar to homework number 9, right? So do not take number of figures and sequence of figures as a must. It's only a suggestion, because for each of the individual projects, you may need one figure and do not need another. But general idea is that there is a set of observables, and you have a set of either modifications of your model, or you can decompose your model on chopped fragments, like A and B. And the general way that you can practice for your model is like show geometry, chop fragment A, chop B, and together. And you can also show the model after certain steps of molecular dynamics, when it can be either broken into pieces or corrugated or just kept intact. Right? just last snapshot of the molecular dynamics, because if you show all, it will be 100 pages. Density of states can be organized as in this example that browsing around. Yes. So another idea. Well, it is a very basic and a simple idea, and you probably all practicing it. The word figure doesn't need immediately single image. It is very standard practice to jam like 4 or 6 figures, 4 or 6 images into one figure and call them panels, and then compare them. Because otherwise you do one image, call it a figure, and then your very basic research will include like 30 figures. That is not possible for standard journals. Some journals charge authors for figures, and you just physically not able to pay for more than like 6, because it's nothing to print couple of copies, but if there is like a couple of thousand, the publisher is concerned about having information condensed. Density of states. Some of you may have magnetic unrestricted, or maybe changing number of electrons, or maybe changing n up down. I do not remember if anyone specifically does n up down right now, but Ben and Gage could be interested in doing it. It could be beneficial for the projects. If nothing is mandatory, but it looks like beneficial. Anyone else does transition metals with unpaired electrons? Your number of electrons is not number of electrons in your model is even.
Number of electrons?
Yes.
960.
Okay, good. So you never get odd.
Never get what?
Neither one variation of your model has odd number of electrons. Good.
So you only do this if you have metals, number 3.
Or you have reactive radicals.
Okay.
If one of the, okay, it's a little story that can be boring to anyone else except the person who asked the question. Suppose you have molecular dynamics, and suppose before you started, you included the keyword I spin equals 2. Which means you run molecular dynamics with spin tracking enabled.
Okay.
Then output of the OSI car will include not only temperature, kinetic energy, potential energy, but it will include one more column at the end, magnetization, which is basically a number of unpaired spins.
Okay.
And if the system is boring, if it is like a signal all the time, magnetization will be 0. But if there is a spontaneous magnetization appearance or spontaneous disappearance of magnetization, this number may change with time. Or there is one more scenario. If your model develops intermediate reactive radicals, magnetization can ramp up also to some sort of value different from 0, right? And if your model has too many molecules and atoms, and it is hard to watch it by human eyes, and you need some objective measurements, you can look on this magnetization and see instant of time when it deviates from 0, and then specifically look on this snapshot of molecular dynamics to see if reactive radicals are popping up. Spectra. Spectra for like A, B, before, after. Orbitals, often very useful. Snapshots of molecular dynamics are needed if you know for sure that there are chemical transformations, or if you are interested in change of the dihedral angle, like of the polymer, like Anderson is doing. So you may show a couple of snapshots to illustrate what is going on. And total energy as function of time if you have suspicion that your system participates in some reactions, actual reactions, bond breaking information. So some of you have already completed most of it. If you were carefully doing all steps of homework 9, then you basically have the structure, but you may add a couple of more panels. Like add a panel of what happens to your observable after thermalization. Okay? And this is not mandatory. Some of you may want to put more figures, most of you may want to have less figures, which is fine. We will chat about goals before the end of the meeting. Okay. Who has never seen this figure before? Okay, then it's not waste of my time. Who has seen this figure before? Okay. Would you like to explain it?
If you really want me to.
Okay, please try. Come here and explain. Because last time you already helped to pronounce Latin, and now you go to more advanced stage.
So this just kind of explains the relationships of various pieces in science and about how science eventually goes to help citizens, which then fund science. So, like, science can lead to things like patents and publications, which help promote industry, and can also produce teachers and in a workforce. Teachers lead to education, and industry leads to energy, gadgets, health, security, which are all things that benefit us as citizens. And as citizens, we pay taxes to the federal government, and the federal government gives grants to people like us who do research to do science. So it's all a vicious cycle, as it were.
The circle of science.
Yes, the circle of science.
So what is the connection of this diagram and your explanation, which was really great, to the written reports?
Well, if we can't explain why it benefits the citizens, then why should the government pay for it?
Okay, yeah, many thanks. Great job. Yeah, let's applaud. So, when you will be, suppose that you have already created all the figures, which, or those figures that you consider important, and you are coming to actual writing, which typically happens. But some people are doing very strategically. It is ideally should be the following way. First, you look on open problems, on what can you do as a final product, and then you scroll back through your research, how you can do it. Typically, human thinking goes another way, but when you put it in writing, you may pretend that you go from applications to your research procedure. So you were selecting one or another project, right? So it was election. No one was twisted arms to do one or another. It was all volunteer. It means that your brains and hearts are leaning towards a specific project. So you may see some benefit, maybe for yourself personally. Maybe you see how your project will save humankind. Maybe you see which scientific challenges it will address, and you may see which expected results you are going to get in order to fulfill these goals. So if you can, without if, you have to write it explicitly. But if you have formulated this idea for yourself, it can be your compass towards including or not including specific results into your paper. So you are putting on a scales like this orbital. Does it make humankind happier? Does it save human? No. Okay, throw it away. Oh no, this orbital is really saves everyone. We should put it. An example is like if you oversimplify it, you do much more complicated. If you're looking on oxygen, O2, and you are doing spin polarized calculations, you will the person who would try to do it will immediately see that oxygen can exist, can set an up down to different values, but only for value 2, which corresponds to 2 unpaired electrons, triplet. Total energy will be minimal. But if one puts oxygen into singlet, no unpaired electrons, all electron paired, total energy will be higher up by like 4 electron volts. And this, I'm ending this example. It will be very short. Do not think that I want to torture anyone with long stories. Singlet oxygen, which is unnatural, is excited by some reason. And if you create singlet oxygen, it is an agent that kill bacteria or malignant tissues. And this is a way how some of the branches of chemotherapy works. So if you are studying singlet versus triplet oxygen, you are saving a lot of people, and you help those researchers who find ways to fight cancer. Right? So it is an example, but you may set up logical path to sell your research as the most important thing without which all civilization will collapse. Right? Without plastic bottles, we will not have our drinks. You can put it as a title. Okay. So, this is another handout, right?
I like this a lot.
Oh,
It's nice.
thank you. It's oversimplified, but if you like, I'm pleased. Well, I do not take credit for it. It's a standard thing. When all of us are writing research papers, and especially short papers, there is a convention in the research community to organize. We have several different organizations. We organize data, organize figures, and now we organize written text. So there are standard practices to organize text to help the reader. So one often has the 4 sections: introduction, method, results plus discussion, and conclusions, right? And it's not mandatory. You can do your freestyle writing, but chances of acceptance will be substantially lower if you're looking for real journals. So if you follow the template, it will be easier to digest by reviewer, by editor, and easier getting to the stage of publication. I want to explain something really simple that it seems evident, but I better verbalize it. So if you are in this class, it means that your career is related to natural sciences in some way, right? And it may not necessarily, but it may mean that you just enjoy process of learning something new, or like making little or real experiments, or intellectual experiments, or computational experiments, and you get satisfaction and reward just of the process. But in order to survive and keep doing this and getting this reward again and again, we need to confirm to the rest of the world that you are the best in this activity. And standard way to prove it is to make your written reports published by independent publishers. And the procedure relates to ancient times and background of the civilization of the our civilization today rests on several seeds and sources, but part of civilization based on Greek and Roman ancient times. And there was an interesting concept, interesting idea at this times. It's I will say a sentence that Ben and Gage didn't hear before. It's the only sentence that I had compared to last half a year. So in ancient and Roman civilization, compared to near neighbors on the map, whatever, 3,000 years ago, there was a concept, or seeds of a concept, of individual freedom. Individual freedom in a sense that a listener of your ideas has rights to accept or reject the ideas or sets of facts or their analysis that you are offering. So basically, I am telling, would you stay for another 2 hours in the lecture room, me? And he has a right to say no, right? I'm not going to ask this. So the same idea, there is a connection to this idea in scientific community. The editor of journal has freedom, has a right to accept or reject your paper. We cannot bribe the editor. We cannot threaten the editor. We cannot twist the arms, right? We need to convince. We need to give arguments that editor will consider as convincing enough that this paper is strong enough to be published. And sometimes, most of the times, editors are too busy, so they do not evaluate papers themselves. They delegate these rights to reviewers. And reviewers are typically chosen from the peers, from the people, from the same group of people who are submitting papers. And the goal of the writing, well, not the overall goal. Overall goal is either to make, to save the humankind or satisfy your intellectual curiosity, right? But cynical goal, practical, little goal, after your research is done, is to convince editor and reviewers, who are free people, that the paper is strong enough. So the way to organize your writing in a specific format is a little step towards going through this freedom to lean their opinion onto your side. So, why system is interesting? Reference, and typically we do references, right? Identify open problem for the system. So, when you are going to save humankind, or when you are going to satisfy your own curiosity, you can formulate your activity as an attempt to answer one or another question. Sometimes you derive this question only after research is done. But for the reader, it's much better if you put this question right up front. So it's completely okay to design a question after it has been answered and just make a little intrigue. Then, again, it's more like writing detective story or just, look what I have, attracting attention. Right? So you can immediately offer hypothetical answer. So most, again, it's very, very different in each situation, but you tell, here's my question I'm trying to address, and most likely this question has this answer based on scientific intuition and what others are writing in their papers. And then the whole paper that is set up at the introduction stage can be formulated, logically organized. I'm talking about writing, not about data, which should be done by the time you're writing. So the whole paper can be organized as finding evidences towards proving your hypothetical answer right or wrong. So it's saying like theorems in calculus. Typically in standard education of calculus, it's not like skills. It is more like set of theorems, and they are first declared and they proved. A lot of people hate math and hate theorems, but it is like standard way to communicate information. Instead of keeping here are all my technical data, guess why I did it, and here is the question, here is the answer. It's a little irritating for a reader. And if you put this important information up front, it is so much easier to get through. So it is your creative assignment to wrap up your mind around your project. Formulate question, formulate hypothetical answer, and tell how your computations will prove or disprove this hypothetical answer. Again, you are not making a fantasy without any background. By the time you are writing, you likely have all results. But now you are doing a little hints how to organize presentation of results in a better way for readers. Methods. Ideally, there is an idea in community that any researcher, well, qualified enough researcher who reads your paper can reproduce your results. So the results are so true that if a reader repeats procedure, like mix so many TNT and hammers with so heavy hammer on it, it will be so much explosion, right? Procedure. Or if one solves Kohn-Sham equation with this basis set, one will get this, and this function, one will get so much of total energy. So the goal is to, ideally, to help reader to reproduce your results, or if you are living in a practical and scenic way, at least to look as if you want to help reader to reproduce results. So either because it is not possible, or it's very bad practice, but sometimes some people do not want competitors to see all secrets. Do not do it. Just be aware that it is possible to do as it looks like all complete information, but some important parts are missed. And as reviewers, you should find such missing parts. Send me reminders. I will be happy to share some templates for methods. Yes?
Okay, so I want to make sure I understand this like hypothetic answer sort of thing right. So from what I understand from my research, my hypothetic answer would be, I guess, PBTE nanowires would work really, really well in high temperature computing environments. And my results would either like prove or disprove that hypothesis. Am I right?
For your specific project, you need to formulate more detailed, more tiny, more narrow question.
Okay.
For example, if you do have P and N doped, you can ask whether the doping will attract electrons and holes to doped sites.
Okay.
I'm not telling that this is a very right question, but try to think and formulate a little more narrow question. So you can have several layers. One layer is how to make humankind happy, and another more specific research question that is addressable. Results and discussion. So, I'm going to tell something oversimplified and not ideal, but what some people do when time is really limited. So you throw in figures, and by the way, each figure should have captions. It's like standard practice, but you throw in all figures and captions in your Word file, or if some of you are really big fans of LaTeX, I don't care. And then you are putting your research results section, and you write, geometry of model is presented in figure 1. Density of states is presented in figure 2. Absorption spectra are presented in figure 3. And snapshots of molecular dynamics are presented in figure 4. Done. I'm going to next section. Well, it is an exaggerated way, but in some sense, so it is the lowest level. Next level, when people copy-paste captions, and there is a paragraph about each figure, and you just do a kid's song. I am singing of what I'm seeing. Like on this figure, I do see green and red blobs, and they stand far away from each other.
I was gonna do that.
Good.
Well, and probably you can, but there are ways to do a little upscale sophistication, but we all are under pressure of time.
I have a question.
Please.
Is there like an absolute point we should just not stop? We should not be running anything at this point. We should just be solely doing analysis. Because I wanted to include one thing, but I'm concerned about time in mine. So just kind of go with what we have right now and just kind of analyze, get everything put together, and just write it up, kind of thing.
It is.
Can you talk about how it would have been, the thing you wanted to produce, how it would have been beneficial? Can you incorporate that in there as like a little discussion point?
Yes.
Okay.
Yes. It is your free choice, but I would focus on writing rather than publishing data.
Oh, okay.
Also, as you already know from your computational experience, the main beauty of computational chemistry is that you submit 100 jobs and go to the pub. Well, right? Or lay on the sofa and watch TV.
Have a nap.
Yeah. So, or submit 100 jobs and start writing. And then if they're done, you can add something later. Right? So, writing right now is the focus. But since submitting of jobs is not really big amount of time and effort, feel free.
Okay.
There are still some hours left in the repository. There is no goal to burn all hours. They are for a group of researchers until the end of the year, and right now hours are being spent a little quicker. But feel free to use. It's a right use of resources. Yes?
This hypothetical answers and hypothetical questions, no? This hypothetical answers and question, no? In the introduction section.
Uh-huh.
So that's a general format in a paper, right? The scope and objective, no?
Mm-hmm.
It's same.
Yes.
More or less same.
Yes. Oh. So, green and red blobs are far from each other because my system has dominant acceptor, and one is oxidizing and another is reducing.
So explain why.
If you can, if you have time, if you have steam, we all live in practical world, and it is clear that one kind of ideals are not always possible.
How the bird turns into the owl, or the owl turns into the bird.
You manage your time, and you may have some other courses, so you are not 24 hours investment on writing.
Yeah.
So. So, conclusions. Why conclusions are needed?
You don't want to leave your reader hanging. You want to conclude, again, why it was important and what you learned from it.
Some irresponsible readers, some irresponsible reviewers do not read the papers. They immediately jump to conclusions. It's not a secret. And reviewers are mandated by editors to write review reports. And in review report, there are several sections that reviewers are the twisted arms to do it. And they need to summarize what paper is about. Do you think reviewers have time to read and formulate their own thoughts? They better copy-paste from the author.
Wait, do they read the abstract?
That's the first step.
It's not long to wait until you will be a formal reviewer. Well, mock reviewing section will be on Tuesday, and in your career you will start reviewing true papers like in a couple of years. And you ask yourself how it's not like level of responsibility of a person. It's a level of how much free time you have. There are deadlines. There are 1,000 other things, and under this pressure, reviewers always often goes to conclusions and just borrows some formulation from them. So when you're writing conclusions, you're putting your words into mouths of reviewer.
All right.
Right? Yes.
Can I add a point? I don't know who said this to me in my undergrad. I just learned it in one of my classes, a research combination. Abstract first, conclusions, results, methods. And that's kind of the general order you go in. Some people look at the methods first, then results. Just depends on what you're looking for.
All right.
So that's, yeah, you don't ever want to read it like a book. You're going to go right to sleep. You're looking for key points and key results from the figures. The figures are going to be your talking point.
Okay.
Okay.
Or learning, rather. Learning points.
So you are formulating your conclusions in the following way. Alleluia. All data supports my hypothetical answer. What a surprise.
I was going to do that.
I think he's a mind reader.
And then you also may want to convince reader that results available for someone else except yourself. Basically, it correlates with introduction. I am the poorest possible writer, and at the beginning of my graduate school, I wrote a draft thing, brought to advisor, and he told, I do not like your conclusions, redo. And I came 15 minutes after and brought a new version. What did you... No, you cannot do so. You just swapped conclusions and abstract. And also you may tell that you trust your results and others should trust because it was so upscale method, best of the best used. Or if it was not best of the best, it was your system was so big and nothing else other than your method was working here. References, because we are standing on the shoulders of giants, and we are not contradicting to overall stream of the science. If you want to contradict, you need to prove, and you still need to refer to others and tell this one was wrong because of that, this one was wrong because of that. But typically it goes like a pyramid. You are standing on previous generations. So, and discussion is anticipating that not every reviewer, not every reader will agree with what you're writing, and you may have an idea what your reviewer is not happy about, and make a safety cushion. Answer the possibly aggressive question ahead of time. You may not believe that I took the best function, but it gave the right gap.
See, Queenie, you're all ready.
So, where this splitting of your writing materials came from? So, I hope it is a favorite part of Ben, and I will use your help again. Would you like to teach the whole section again? Or Gage? Okay, but I definitely will need your help in pronunciation. So, the idea of communicating some amount of information to other people is not new, right? And amount of public speeches or public writing is not new. It exists for like several thousand years. And there are, it's maybe one of the most ancient branches of human intellectual activities, the rules how to organize your thoughts in writing or in speech so that it will find way to the hearts of your reviewers. And reviewers in scientific communities is reviewers of papers, but it could be judge on your trial, or a person whom you want to sell your house, or whatever. So again, assuming that everyone is free, can accept or reject your suggestion, you need to give some argument that would look convincing. And there are two, well, more than two, but there are two streams in thinking about this conversation procedure. One is more Greek school, another originates from Roman. So in Greek school, they are more philosophically think how the creation of your written project or product or oral product goes on, and they split it onto like designing the actual materials and logically connecting them, and then designing how you will present, and specifically how you will align, in which order you will align your pieces of information, how you chop parts of, how you chop everything you think about this subject in a best possible order. So what we did on the previous slide and this handout is how the information, how your thoughts are chopped on this introduction, methods, results, conclusion. And then today we do not care how to deliver and how to memorize because we have computers and there is a printing technology for the last like 600 years. But for people in 3,000 years ago, they designed public speech and then memorized it each time. So, goal of each intellectual product, either speech or writing, is
delectare, docere, movere.
To
How do you know how to say that?
I took 4 years of Latin in high school.
Oh.
so, in order to take, it is a prerequisite for computational chemistry. You cannot take it without Latin. Your product, in our case it is written reports, should please the reader or like entertain reader, should give something new, and should urge to move, should inspire reader to do something. So under inspire reader to do something, it's very clear. You need to inspire reviewer to write that it is best paper I ever saw, and they recommend it for immediate publication in current form without any changes. And Cicero, one of the famous speakers who designed public speeches, left some notes how to split thoughts on in the best way that they will be digestible by public. So what we do is inherited from here with some changes to academic nature of our activity and with some simplifications of the modern world. So the first one,
Exordium.
which corresponds to part of our introduction or the abstract that basically tells the idea of saving the world, explaining how your project will save the world. The second one
Narratio.
is giving some references if other people were doing something. And the third part
Partitio.
Is often included in long scientific papers when at the end of the introduction section you tell how the rest of the paper is organized. Or if you are more to the book style rather than short paper, you have just table of contents. So you help reader to navigate through the rest of material.
Confirmatio.
So this is combination of methods and results. In the ancient styles, there were no computers. Amount of facts and amount of proofs was less, and it was more accent on ways why you do it and what you get out of it. In our modern world, we get less and less introductory and concluding part, and we get more and more on the actual facts and their analysis. But here is when you confirm your hypothetical idea that it was right. So, and also here you include your methods. So you confirm that you save the world, that your answer to your hypothetical answer is correct. So all evidences that tell that your case is winning.
Quantitatio.
So this, by now, this also is part, in short papers it's part of the results and discussion. In longer papers there are separate section discussion where you anticipate that reviewer as a free person may or may not agree with you. You anticipate in which aspects reviewer will be not agreeing with you, and you are trying to provide, to make safety caution, to provide some arguments against possible aggressive questions. We are not babies. We can think a couple of steps forward. And you, it doesn't take special, you do not need to like sit in the sealed room for a month to predict what a reviewer will ask. You see your weak places yourself, and you understand yourself why it is missed, and you can tell like, okay, I never included spin polarization, but you, reviewer, have never seen organic polymers with magnetic properties, right? And it will, like, reviewer may ask why the N up-down key was not used, why the magnetic properties of my system were not explored. But through all literature I read, there is magnetic organic polymers are not very popular, and my material is not magnetic. So enough. Okay.
Peroratio.
So it is a conclusions. So I like this is taken just from Wikipedia. So I'm doing poor job of telling in public this excellent help of Ben of what I just read in Wikipedia. But it, as we agreed, it concludes that your hypothetical answer is correct. It tells that it is available, and then you use some argument, and then you cast or blame anyone who disagree with your results, and you arouse sympathy for the author client of the case.
Question.
Yes.
Are you comfortable with the R word down there?
Hmm?
Are you comfortable with the R word down there?
Which
In
word?
the link, in the Wikipedia link. Rhetoric.
That's just an English word.
No. I mean, like, do you feel comfortable with the pronunciation of that one?
How do you pronounce it?
Rhetoric, right?
Okay.
Rhetoric.
Rhetoric. How are you thinking of pronouncing it?
I never pronounced.
Aha. Okay. Rhetoric. Yeah. Would that be a special kind of like? Does that have a base kind of?
But it is Greek. It's not Latin.
Greek.
Yeah.
Okay.
It's Greek. RH doesn't appear in Latin.
Okay.
There are different ways to pronounce ancient Greek writings. So the original way how they were pronouncing is completely lost. So modern Greeks pronounce it a different way. And there were medieval European thinkers who redesigned the way how to pronounce. But they swapped several vowels. And like the vowel that in original by some sources is pronounced like sound E is not pronounced like E. And whatever we try to make out of Greek writings is not how it originally sounded. Thank you, Ben. Okay, almost done. So you have all ideas, well, which I can communicate. Maybe there are more ideas how to wrap up your reports. And I'm not going to keep the intrigue. Here are the questions that you will answer by reading works of your classmates on Tuesday. So if you would, this time all of you will become actual reviewers for big journals, and then you'll answer like publish after major revision, or minor revision, reject, or publish as is. And as author, you fight for publish as is. Right? And as objective reviewer, you do not have rule. You just objectively evaluate. Some people are unhappy through the life and they try to reject everything, but it's minor. It's not typical.
So really, we should probably scratch out reject. Would we reject our peers?
You can.
Because that seems a bit harsh. I mean.
Well, reviewers are typically blind, so you do not write who is the reviewer. Idea that could be helpful for final for writing great paper is understanding that things that you are writing is not a standalone thing. It is a piece that will be read by your classmates or by someone else. And if, as a reviewer, you read this material, you should be able to summarize how you see what this work is about. What's the main idea? So on Tuesday, you will try to dig out and solve this puzzle. What is actually done by the work you are reviewing. During the weekend, while writing, you are trying to write in such a way that anyone who reads can easily decompose your writing and find what is the main idea. And there is nothing wrong to highlight it in the explicit way. You write somewhere. The main idea is, and just help reviewer to copy paste it. Some other things are there are like technical things. Title, author, address. Oh, why title, author, and address? I was reading a little bit more in the Wikipedia about this ancient rhetoric, and there, I'm just sharing it. It's not very relevant here. The modern mass media are not part of the rhetoric, because in mass media there is no single author with a team, and there is no responsibility. But in the ancient rhetoric and any parts of activity that inherited from them, author carries personal responsibility for the content, for the style, and these questions, therefore there is an author written. And these things become developed a lot during the medieval times, where a lot of public speeches were on the theology things, and in case you say something wrong, there was an inquisition, and it developed a culture of being very responsible for whatever you write. I don't know if you find it funny, but so try to put your names. So, do you, as a reviewer, do you see big picture? Why this paper is important? Does author motivate interest? Other references, and then reviewer should be able to list challenges that author is offering. So the answer to which author provides hypothetical, the question that our author is providing hypothetical answer. So as reviewers, you'll try to see if this part is there. Again, the idea about hypothesis driven, I'm not taking credit for it. And even CISR doesn't take credit for it. National Science Foundation takes credit for it. They, while reviewing proposals, they are demanding that anything that is proposed for funding is hypothesis driven. So the structure of providing hypothesis and hypothetical answer is standard custom in the academic environment. Which audience does it target? You can, if you do not like, you can tell like, it is too sophisticated, it's only for experts, or it's too simple, it's for kindergarten, or information is not sufficient, I don't know who needs it. For figures, a lot of you are very experienced in making scientific information, products, figures, data, but when it was an introductory stage, it was a typical thing to not to care about line thickness. And when it is printed or reproduced with reduction of size, thin lines disappear. And of course your paper will not be rejected by big journal of the quality, but you can get a little reprimand for quality. So try to make ugly, exaggerated thickness of all symbols, so that they will be seen even after reduction in 10 times or whatever. Just explaining what lines are coded by dots and dashes, other labels on the panels, other captions in figures, other figures that are unclear. And I'm sure because we have time pressure, some of us will forget to put captions, or they will be unreadable, and we will come back to it during this reviewing procedure. So the goal of today's meeting, which I'm not giving as an example of a very organized thing, but it focused on some items that you need to make an effort to logically organize. So when you will read together, you may judge whether you see logical organization in several rubrics. And as a reviewer also has right to give suggestions how the paper can be improved. And one of the typical suggestions is like swap sections, which may help better understanding. Through the years of this course, it's always under pressure, and it's not rare to see in these reviews like conclusions clearly present and the answers. I do not see conclusions in this paper. Because of time pressure, not all of us have time to complete them, but as reviewer you may make your comments. Like other challenge hypotheses, are they addressed? Work conclusion supported. In science, it is a big benefit if paper communicates new knowledge. So it is, even if it doesn't save humankind, you can tell there are some meticulous screening for new knowledge, and finally this thing was not known before. This is also good enough for accepting it. And here the best answer is, I'm jealous. Why didn't I do the same project? I like it so much, it's so interesting. So some of you may write it in such a way that the reader will think that it is really nice. Inspires future direction. So it is your question. If you do not have time, but you may mention it in the paper, and the reviewer will see it, so that there are directions for future research, which is also considered as a benefit. And benefits of general public, we already discussed it. Results are clearly presented, supported by data. Elementary processes are illustrated. Quality of illustration is perfect. All figures are explained and there are no complaints. You should feel bored and tired by this time, right? We are finishing very soon. So in methods, please try to include equations. Send me emails if you need templates. I'll try to send. The goal of the methods that the reader can reproduce the results. And if you appeal to the community of computational chemists, we discussed it, and Kurt taught me a special collegial word, but I already forgotten it. No? So military aircrafts, fighters from different countries meet in the gray territory. So it's all very computerized. Yeah, this will be not direct connection, I thought, but you will see connection. And there is a very short time, shorter than human brain can operate, to identify whether it is friend or find, whether to launch defense systems or just coordinate and fly together. So there are like Wi-Fi passwords that identify is it on ally side or enemy side. And these Wi-Fi passwords are not very complicated. It means they need to be, in all ancient times it was just banners by the troops. You see the right color. Nowadays it is similar, it's not literally Wi-Fi, but it is radio signal to identify. So if you are submitting a journal in the community of other computational chemists, you need to send a Wi-Fi signal that you belong to this group. So if you do not include equations, if you are not telling in the standard format, like in order to get these results, we solve this equation, but this software, you may get a wrong signal and you will be considered as a foreigner in this community. Please.
So basically, in other words, include all the famous people that have led us to do what we've done, essentially.
Well, in this short report, there is no time to do everything, but not people. Show equations.
Well, they were, like, for example, Hartree-Fock, you know, like.
If you're not solving Hartree-Fock equation, you do not need to show.
Well, yeah, but if you were.
But so the logic is, suppose that your reader doesn't have didn't have funds to purchase a license for a specific software, but your reader wants to reproduce results. Any software that is being run is, even at our sophisticated days, can be written with less than half a year. If you quote right equations, a smart person can recode the software and gain the same results. So you need to provide enough information and try to include equations. Again, it's not super mandatory, but it's highly recommended.
Yeah, yeah.
Make sense?
Yep.
And if there are no equations, not tomorrow, on Tuesday, if you see no equations, you can complain. There are no equations in this paper. So, I have problems myself explaining this often, but visitors to your presentations likely will answer this. So you may start thinking, why this method versus another one? Methods are very trustable. I do not need anything else. I can reproduce results. Thank you for your questions. Wishing you inspiration, enlightenment, good luck, coffee. So please bring printed copies on Tuesday.
I see.
Are you going back to the department?
First.
I was wondering if you
You can go to my office as well.
I don't have one.
Oh,
Do you
okay.
have your car?
Yeah, there are two.
Everyone needs a really
There are two sample booklets they issued.
I know.
I have them. Oh,
just did.
those. Maybe someone took them.
I have one
But I have
slide,
a
but-
couple of copies more in the office. And I also can. You can share it. Like if you need one, you can take it with you. If anyone else needs. I was not intending to bring it back.
Yeah, I'm gonna leave.
And I can share electronic form of this as well.
Are you walking back to the?
No, I'm going to the gym.
Oh.
Yes, I did figure out how to make the
I have one slide done.